Okay, for the volume homework, we're gonna do this. For all questions, we're gonna do. That's the terrible. So let's go over the volume homework. For all these questions, we're gonna draw a picture of the rotation. We're gonna state the disk or washer method, and then we're gonna find the volume of the thing rotated. So for A, let's draw the picture. Right. So we have this. Come on. We have that. X plus 1. So start at 1. Looks up like this. We're going from 0 to 3. So 0, 1, 2, 3. Something like that. Now, so this is the region we're talking about. And we're going to spin that across the x-axis. So all these don't say it, but they all mean across about the x-axis. So we're going to spin it about here. So that's about as good as I'm drawing at. So if we want to draw the spin, now this is all, when I say draw, that's all we kind of mean. Like, what's the area? If you want to draw the spin, what's going on is you're spinning across there, so it actually goes down like this, kind of like that, and kind of like this. So you'd get a thing like this also. So you have like that little like vase thing there. That's what we're getting out of this. So what does that mean? Well, a couple things. First, since you see the little section, it's kind of like area. If you do an area underneath a curve, that's going to be the disk method. So for B, we're doing the disk method. Now, how do you find the volume? Well, if you notice, we're just doing volume, basically circles here. So it's like doing a circle. We're doing pi r squared, but our r, we'll say capital R is this guy. So we're going to do pi capital R squared. Now, how do we do it for the whole region? Well, we integrate that thing. So our formula is going to be this, pi capital R squared dx. That's how you find volume. So like area, but you just square the r. So how do we find r here? Same way we always find our r. We're going to do the top minus the rotation. So in this case, my top is x plus 1. My rotation, I'm rotating about the x-axis here, so 0. So x plus 1 minus 0. So my r here is going to be x plus 1. So if I'm putting in the formula, I'm going to get pi integral of my r, which is x plus 1, squared from 0 to 3 dx. To get to 21 pi if you want to do it by hand, or if you want to play in your calculator, you get 65.973. Rounded to 3 decimal places. So that's the idea. So let's do the next one. So we have x squared. X squared kind of looks like this. We're going from 1 to 3. So here's 1, here's 3. Right, so we're going to spin that region around. Now again, if you want to see the actual rotation, that's all I mean for drawing it. If you want to see the actual rotation, it would look like, so that's our r. So we'll spin it around like this. 101, so spin it around like that. And then it's x squared, so it's kind of like that. That's not the best. My drawing's not very good. So like that. Something to that effect, spin around. Yeah, this part was a little mistake. Anyway, get something so that looks like that. That's why I don't draw it. I don't draw the rotation. Anyway, this would be another disk method. So remember the formula for that's pi big R squared dx. Or in this case, we're going from 0 to 2. So what's my big R? It's always a question. Big R is this guy right there. So that's top minus bottom. So x squared minus the rotation, which is 0. So it's going to be pi, the formula is going to be pi 0 to 2 of x squared dx. You plug that in, you get 242 pi if you do it by hand, or on your calculator, you get this. So that's the idea. Let's do the next one. So same thing here. I'm going to draw real quick. So square root of x plus 1. So plus 1 moves to the left 1, and it's a square root graph. Something like that. And we're going from 1 to 4. So 1, let's say 4 is right here. So we're looking for this region spun around. So I'm going to draw that. So if you want to spin it around, I could probably just draw the spin. So it looks like this. Looks like this. And then it would kind of go like that. So it would be like that. I don't think that's too bad, actually. Anyway, this is another disk method. So the formula is going to be pi integral from 1 to 4 capital R squared dx. So what's my capital R? It's this guy here, right? The top equation, x squared plus 1, to the thing you're spinning across, which is x equals 0. So we're going to get square root of x plus 1 minus 0. which is just square root of x plus 1. So my formula is going to be integral from 1 to 4 of my capital R, which is this guy. So square root of x plus 1 squared dx. Now if you want to simplify, I guess you could. It'd be pi 1 to 4 of x plus 1 dx. So it's an easy thing to integrate. You actually don't need that. You actually don't need the parentheses signs. Couldn't think of the name for a second. It's easy enough to do by hand if you want to. And if you did that, you'd get 21 pi over 2, or for the lazy, 32.987. So there's that. Next one, f of x equals x to the negative 1. So probably easier to see as 1 over x. So we know how to graph that. So that's a reciprocal function, so it's kind of like this and like that, from 1 to 2. So let's say 1's here and 2's here. So we're going to get that region and spin it across like that. So it's again another disk method. So that's going to be pi capital R squared dx. In this case, we're going from 1 to 2. So what's my capital R? Well, it's the function to what you're spinning against, so 1 over x over 0. So just 1 over x. This method are the easy ones. It's always the same. So we're just going to have pi times the integral from 1 to 2 of 1 over x squared dx. Plug that in, you get pi over 2, or 1.570. Next one, 1 over x squared. So if I want to draw that real quick, that looks reciprocal function where they're both on the top. Number going from 1 to 4, so let's say this is 1 and this is 4. If you notice, I stopped drawing the spin because, come on, it was disgusting. So next, though, it's another disk method. So we're going to do this formula, capital R squared dx. We're going from 1 to 4. So my capital R is again this guy. So 1 over x squared minus 0. So just 1 over x squared. You'll see why when we do a washer method, why I like to draw the R out. So it matters more when you do a washer method, but it still helps. So C is pi 1 over x squared squared from 1 to 4 dx. And you'd get 21 pi over 64, or 1.030. Next one, 4 minus x squared. We're going to rotate it about the x-axis again. So that's like saying, what, negative x squared plus 4? So I could draw a little better. 1 plus 34, negative x squared. And we're going from 0 to 2. So 0, 1, 2. So this thing spun across the x-axis. So it's another disk method. We'll get washer in a sec. We'll get washer in a bit. So again, we're going to go pi integral from 0 to 2 of r squared dx. My r is from the top to we rotate. So 4 minus x squared, 0. So just get 4 minus x squared. So it makes my answer pi times the integral from 0 to 2 of 4 minus x squared squared. It looks a little funky, I know, sorry. That'll get you 256 pi over 15, or 53.616. Next one. So let's see, f of x equals ex. So if I was drawing it out, ex crosses at 1, like that. And we're going from 0 to 1. So let's say 0 to 1. So we want that area right there. This is another disk method. So the formula is pi capital R squared from 0 to 1 dx. So what is my R? R is top to we rotate against. So e dx 0. So that makes my formula pi from 0 to 1 of e to the x squared dx. Or if you want, e to the 2x with the same thing. If you do it by hand, you get pi over 2 e squared minus 1. Or on your calculator, you get 10.035. So now we're going to have two functions. So we're going to start using some washer methods. We got y equals x squared plus 2 and y equals 10 minus x squared. So let's draw these real quick. So 10 minus x, let's do x squared plus 2. So plus 2 x squared. Looks kind of like this. Then we have 10 minus x squared. So it's like the last one. It's like negative x squared plus 10. So 3, 4, 5, 6, 7, 8, 9, 10. Then we're going to go up and down. It's like that. It'll be negative x squared plus 10. Now, if we're going to solve this, it's like when you do area, you got to find the intersection of these guys. So I got to figure out where they intersect at. So the way we find intersections is like we always do. Set them equal to each other. So try to get the x on one side and the thing on the other side. So plus x squared minus 2. So I get 2x squared equals 8 divided by 2. X squared equals 4. Square root. X equals plus and minus 2. So negative 2 and 2. So B, this is a washer method. So here's the thing with the washer method. It's not like area where you go top minus bottom. What we want to do is this. With the washer method, we're going to integrate big R minus little r squared times pi. So what do I mean by that? So what big R is like kind of like area. What are you rotating it around? So this is the top minus rotation. This will be the bottom minus rotation. Like what are you spinning around? We're spinning around the x-axis here. You know, it doesn't say it. It really should be like rotate around the x-axis. So we need the big R. So what's the furthest one from the x-axis? That means my big R is going to be, let's do 10 minus x squared minus 0, right? Because it's the y-axis. My little r would be the smaller one from the x-axis, this guy. So my small r would be x squared plus 2 minus 0, which just gets me, my formula for c is going to be pi times big R squared, which would be 10 minus x squared minus little r squared, x squared minus plus 2 squared dx, coming from negative 2 to 2. And the answer for that would be 256 pi or 804.248. So there you go. Right? So in this case, in the washer method, it's a little bit like area. You go, okay, I got to find it in the volume between, but you're doing, when you do like each R, you want to do each R though. So what's the big R? What's the furthest from the thing you're rotating against? And what's the small r? What's the smallest from the thing you're rotating against? So in this case, that's further apart. So big R. So that function minus 0. And then this function minus 0. Get to your r's and then just plug them in. We'll do the same thing with the next one. Another two equations, so you know it's going to be a washer method. Again, it's about the x-axis. So first let's draw it. So I got x squared. Then we have 2x plus 3. So here's 3 and then 2x. Again, it's not close to a perfect graph. Just a sketch so you kind of understand what's on top and what's on bottom. So it looks something like that. We're going to spin this part around. Right, so let's find the intersection. We're going to set them equal to each other. Set equal to 0. Factor x minus 3, x plus 1. Split x equals 3 and negative 1. So this is negative 1 and this is 3. This will again be the washer method. And then C, let's find our r's first. So it's my big R. We're spinning around the x-axis, so it'll be, this guy will be the further from the x-axis. So my big R is going to be 2x plus 3 minus 0. My little r is going to be shorter to the x-axis. That will be the x squared graph. Something like that. Right? That's going to be x squared minus 0. So my formula is going to be pi times the integral from negative 1 to 3 of my big R minus my little r squared. Right? That's the formula. So my big R here is 2x plus 3 squared minus little r x squared squared dx, which gets me 1088 pi over 15 or 227.870. Right, so this is my big R, This is my little r. So there's that one. Let's move on. So now we're going to go from all of these three. So we're still actually spinning it across the x-axis. But now we have three functions we got to deal with. So let's draw it out. 16 minus x, or negative x plus 16. So 16-ish, and then a negative x. 3x plus 12. So that's 16 to 12 must be lowered, but it's going positive. And then x equals negative 1. So negative 1 will be over here. So like right there. So I'm looking for like this region right here. This is where I'm going to spin it across. So, again, notice two equations, so this is a washer method again. So you got to find the limit. So one of my limits is negative 1. Other limits is this. Other limit's that guy. So we have negative 1 here. That's where I'm going from. Ending right there. So how do I find that? Like always, sum them equal each other. So I got 16 minus x equals 3x plus 12. Let's do a little algebra. Plus x minus 12 minus 12. 4 equals 4x. X equals 1. So this is at 1. We're going from negative 1 to 1. And again, I always like to figure out my r's. So let's do that. My big R. Because remember, the formula is this. We're going from negative 1 to 1. A big R squared minus little r squared. My big R. Now, furthest from where we're spinning about the x-axis. So down here. So what's the biggest one from that? That would be this guy. So what's that equation? That is 16 minus x minus 0. My little r be the one closer to the x-axis. This guy right there. And that would be 3x plus 12 minus 0. Third equation. So that's going to be pi times the integral from negative 1 to 1 of my big R, which is 16 minus x squared, minus my little r, 3x plus 12 squared dx. Plug that into your calculator. If you do by hand, you get 256 pi over 3, or 686.961. So there we go. Let's keep this moving on. Next one, a little harder graphs. Something like this. I'm going to graph this one a little first. So 5 halves, so 2.5. Subtract minus 1. And then you have 1 over x. So 1 over x is the reciprocal function. It looks kind of like, goes really close to that. It goes like that. Oh, that's a bad graph. Like it's pretty close to the edges. Sudden side effect. So it's that guy right there. Not my best graph, but sudden side effect. So we got to find the intersections as always. So set them with each other. 1 over x equals 5 over 2 minus x. That is discussing algebra 1 problem. So probably the first thing you want to do is get rid of the fractions. So remember the easiest way to do that is multiply by the LCD. Right, what's my biggest common denominator here? That would be 2x and 1. So 2x. Multiply by my 2x. So you get 2 equals 5x minus 2x squared. Set equal to 0. Now, I don't like to have a negative x squared, so I'm going to move actually all this stuff over to that side. So I'm going to get 2x squared minus 5x plus 2 equals 0. Then we got to factor it. So I like to multiply these together. I got 4x squared. Combination, I get 4x squared, that gets me negative 5. It would be negative 4x and minus 5x minus 1x. Plug it in for the middle. So 2x squared minus 4x minus 1x plus 2 equals 0. These have a 2x in common. X minus 2. Always bring down the middle sign. So now 1 divided by negative 1 is x. 2 divided by negative 1 is negative 2. Hey, these match. X minus 2, 2x minus 1. So it's factored. Split. X equals 2 and 1/2. So those are my limits. It looks like this is 1/2 and this is 2. Again, we notice we have two functions, so it's going to be a washer method again. Let's find my r's. So my formula is going to be from 1/2 to 2 of big R squared minus little r squared times pi. So my big R. Now big R in this case is going to be this function to the bottom. So that'll be my line. So 5 over 2 minus x squared. My little r. I guess I shouldn't square it yet because it's just my r. So it's going to be, there we go. Yeah, no need to square it. When I plug in the function, I'll square it. My little r is the reciprocal function to the bottom. So 1 over x minus 0, which makes my equation pi times from 1/2 to 2 of big R squared minus little r squared dx. Do it by hand, you get this. Good luck on you. Do it approximate your calculator, you get 3.534. So there we go. Next one. So we have y equals x plus 2, y equals 6, the y-axis, and rotated about x-axis. So let's look at this one. Let's draw as always. So x plus 2 is like this. Y equals 6. So 1, 2, 3, 4, 5, 6. The y-axis, so it's this line right there. And then rotate about the x-axis. So I'm looking for only this little area right here. A little the volume of that rotated around. So again, this is the washer method. Now this case is actually a little easier to find the limit. It's going to be 0 to me 0 right here. And then here, you want to find that point. I actually know one value. I know the y is 6. So it's a point in 6. So all I got to do is figure that out. So I have y equals x squared plus 2. I know the y is 6. So x squared plus 2 here. 4 equals x squared. So x equals plus and minus 2. So we have positive 2. Now, again, we're trying to find the volume, so we need big R and little r. So this is our formula. We're going from 0 to 2 of big R minus little r. Big R is the furthest distance from the x-axis, so that'll actually be this guy. That's the bigger value. That's my r. That's going to be 6 minus 0. Now what's a shorter one? That'd be the x squared is actually the shorter one here. So that'd be x squared plus 2 minus 0, my small r. So plug into the formula. Pi. Big R is 6 squared minus my little r, which is x squared plus 2 squared dx. Plug that in, you get 1024, oops, sorry, it's the next one. 704 pi over 15, or 147.445. So that's the idea. Now we're gonna have a little more fun. So number 24. So in 24, we have the exact same question, except now we're going to rotate about y equals negative 2. And that changes your r's. So let me draw that again, just real quick. There we go. I'm using this of those. So you have x plus 2. I have y equals 6. And then we're going to rotate across at y equals negative 2. So this line right there. Again, that's going to change my r's. So that's how that's going to work. So it's still the y-axis. So we're still only doing this section spun across this line right there. So again, it'll be another washer method. So we're going to use this formula. It's still going to be 2 because we figured out last time. So we're still going to go from 0 to 2. That doesn't change. Big R squared minus little r squared. But the r's is where it's interesting here. So my big R. So first it's from the thing we're rotating again. So big R is going to be 6 all the way down to negative 2. So my big R is 6 minus negative 2, which actually just gets me 8. My little r is a smaller one all the way down to negative 2. So that's going to be x squared plus 2 minus negative 2. Or if you want, x squared plus 4. Well, negative makes it positive. So if we put it into our formula, we get this. Pi times the integral from 0 to 2 of my big R, 8, squared minus my little r, x squared plus 4, squared dx. Plug it in, you get 1024 pi over 15, or 214.466. So that's the idea there. Next one, now we're going to rotate about y equals 2. So let's draw that again. So 1, 2, 3, 4, 5, 6. So like this, y equals 6. We know we went from 0 to 2. And now we're spinning across y equals 2. So right there. Not the straightest line ever drawn. It is a washer method again. And then let's find ours. So again, our form would be this. Our big R is going to be the first way, which is still this guy, which would be 6 and 2. So our big R is going to be 6 minus 2, which is just 4. Our little r is going to be this guy. And that's going to be x squared plus 2 minus 2, or just x squared, which makes our formula pi 0 to 2 of big R, which is 4 squared, minus small r, which is x squared squared dx. Plugging your calculator, you get 128 pi over 5, or 80.424. There's that one. And then we move on. We got a few more of these to do. So the next one, same idea, but now we're going to rotate about the x-axis, but we're going to change things around a little bit. Similar idea, but we're going to change it a little bit, actually. So y equals x plus 2. So x plus 2 looks like this-ish. The y-axis, then x equals 2. 1, 2. So like right there. So I only want this area right there. Now notice this one, it's only one equation really, right? We're not going top minus bottom, it's just one equation. So this is actually a disk method. We haven't done this in a while. That says pi times the integral of capital R squared dx, and we go from 0 to 2. So what's my capital R? Same thing as always. Top minus bottom, right? So it's top minus the bottom. So x squared plus 2 minus 0. So like that. So we get the integral, pi times the integral of 0 to 2 of x squared plus 2 minus 0 squared dx. Plug that in, you get 376 pi over 15, or 78.749. So like that. Okay, 30. Then we start to get a little real again. So y equals x squared plus 2, staying y-axis, x equals 2. Actually, I'll probably say the x-axis is also in play here. We're going to rotate it about y equals negative 2. So that's important. So let's draw it. There we go. So 1, 2, kind of like this. And then x equals 2. So like that. So that's the little region we want, because y-axis and x-axis. So I want this little region right here. And now I'm going to rotate that region about y equals negative 2. So we're going to spin it across this guy. So there's actually two kind of equations here. We have this equation, and we have this equation, right? Because that's what closes it up. So this is going to be a washer method. So remember, the washer method is pi times big R squared minus little r squared dx. And we're going from 0 to 2, because it's like all the other ones. We can find the intersection 0 to 2. Actually, we don't need to find it, 0 to 2. So what's my big R? Well, the furthest from the thing you're rotating across. So that's going to be this guy all the way down to this guy. So my big R is going to be x squared plus 2 minus the thing I'm rotating against, negative 2. Or if you want, x squared plus 4. What's my little r? Well, the other rotation, this guy. So that's 0 minus negative 2, which you also just get 2. So let's plug it into the formula. I'm going to get pi times the integral from 0 to 2 of capital R minus little r dx. Plug that in, you get 776 pi over 15. Or whatever thing it is, that's when you put in your calculator. The next one, same idea. I should again add in the x-axis. But now we're going to rotate across y equals 6. So this will get a little more fun. So we got that, like that. Go 1, 2. Something to that effect. I get x equals 2. So right here. So again, we're going to look for that little region x bounded by the x and y axis. But we're going to rotate across y equals 6. 6. So we're rotating this region around this guy. So again, to me, kind of two functions. You can see like it's a small section. To me, two functions again. We're gonna have function 1, this guy, and function 2, that guy. And we're gonna spin that around. So this is gonna be another washer. So the formula again is gonna be pi times big R squared minus little r squared dx from 0 to 2. So let's talk about what those r's are. Big R, now again, it's the furthest, so it's the biggest r. So there's kind of two r's here, right? You got the distance from that to x squared, and we got the distance from the thing that's spinning around all the way to x equals 0. This is actually the biggest r. This is my big R. So my big R is going to be 6 minus 0. Right? So that's the big R. So that, the distance from the thing you're spinning around to the thing the value you have. So that's actually my big R. My little r is actually this guy. So my little r is going to be 6 minus parentheses x squared plus 2. Parentheses are important there. So over here I just get 6. Over here if I distribute the parentheses, I get 4. I can do math. Minus x squared. So, put in the formula. Pi big R squared, so 0 to 2 of big R squared, which is just 6 squared minus little r squared, 4 minus x squared, squared, dx. Put that in your calculator, you get 824 pi over 15. And there's that problem. I got a few more left and then we're done. So the next one, we have y equals x squared, y equals 12 minus x equals 0, about y equals negative 2. So again, we're doing some more where we're spinning around not just the x-axis or y-axis. So we have this. We have this. So we have x squared. Looks like that. We got 12 minus x, so start at 12 and have negative slope. And we have x equals 0. So that's going to be like this region right here. So x equals 0 just means you don't go past this guy. That's all that means. I got to find the x-intercept again. So we got to find out where they intersect. So we got to go x squared equals 12 minus x. So x squared plus x minus 12 equals 0. So I get x plus 4, x minus 3 equals 0. So x equals 3 and negative 4. So we have the 3 side. Negative 4 is over here. And we're spinning across y equals negative 2. Forgot that part. So right there. So as you can probably tell, it's a washer method. We have these two functions. We're going to spin it around there. So it's a washer. Just make sure your equation pi big R squared minus little r squared dx. Where we're going from 0 to 3. I probably should put y-axis somewhere also. What's our r's? Big R, furthest distance from the thing we're spinning across. So that is this guy. So big R is going to be 12 minus x minus negative 2. Also just known as plus 2. So 14 minus x. Little r will be the shorter distance to the thing we're spinning across. So that's going to be x squared minus negative 2. Also known as x squared plus 2. So then we just do the formula. Pi times from 0 to 3 of big R, which is 14 minus x squared, minus little r, x squared plus 2 squared dx. Put in the calculator, you get 1872 pi over 5, or just 1176.212. So there we go. That's the general idea. Next one, very similar question, just now we're doing about y equals x equals 15. So same setup. There we go. We're a little short on to go spin all the way down. So 12 minus x, so let's say, well, x squared. Let's do x squared first. So it looks like this. 12 minus x is going to go like this. And we cross that at 15. So we're going to spin it across this guy. Y equals 15. So again, we're looking for this region. And then we know from last time, it's the exact same intersection, 0 to 3. Okay, so the notes, primary notes again is the washer method one more time. So we're going to go pi times the integral of big R squared minus little r squared dx. Going from 0 to 3. Now what's our big R? So again, furthest distance from the fifth, like biggest R. So let's draw your R's. If you're not sure, just draw your R's. So this is one R. And then this is the other R. This one looks like the big R to me. What's that? That's 15 minus x squared. I went a little too far. 15 minus x squared. So my big R is going to be 15 minus x squared. Right? So it's just, what's the first distance from the thing you're spinning across to the one equation? And that's top minus bottom. So 15 minus x squared. My little r is this guy. 15 minus 12 minus x. Let's simplify. 15 minus 12 plus x. So 3 plus x. So plug into the formula. Pi integral big R. I have to do my limits. Which is 15 minus x squared. Squared. Minus little r. 3 plus x. Squared dx. Plug into your calculator if you want the, you get this. Or you get, so there we go. Okay, last one. We have y equals e to the negative x, y equals 1 minus e to the negative x, x equals 0, about the y equals 4. So let's do this thing. So let's graph this. There we go. So if you know anything about y equals e to the negative x, that's like, e to the x looks like this. A negative on the power here flips it left and right, so it actually looks like this. And this is going to be the same graph, but flipped and up one. So it's me kind of like flipped, but then up one. So it's kind of like this. So put that all together. Let's say this is 1. So my y equals e to the x graph, a negative e to the x graph, as that looks like a decay. And then this graph, it will look kind of like this. So it'll be kind of like that. So that's what the graph looks like, where this is e to the negative x, and this guy here is 1 minus e to the negative x. So there we go, we want that region right there, about x equals 0. So remember, x equals 0 is this guy right here. We do got to find the intersection. This we can solve by hand if you want, which would be, that would be what? We're going to set e to the negative x equal 1 minus e to the negative x. So let's add this to both sides, plus e to the negative x, plus e to the negative x. I get 2e to the negative x equals 1. Divide by 2, and I get e to the negative x equals 1/2. Take the natural log of both sides. Negative x equals natural log of 1/2. Divide by negative 1. So I get x equals negative 1 natural log of 1/2. Kind of ugly, so let's move that up there. Natural log of 1/2 to negative 1, which would flip it, so natural log of 2. So if you want to be a hero, you can solve it by hand. You can also put in your calculator and get some decimal, which is 0.693-ish. So either way works. Now if we're doing this one, right, this again, we're flipping across y equals 4. So let's draw that out. Y equals 4 will be up here somewhere. Y equals 4. So this would be a washer method. We have two solid equations we're going to do. And so we're going to do the integral, pi times the integral of big R squared minus little r squared. Let's big R again. Big R is the furthest from like the biggest R. So let's draw your R's. So you have one thing we're flipping across to one of the equations, and then we're flipping across to the other equations. This is my big R, so that'll be 4 minus parentheses 1 minus e to the negative x. So that's my big R. So 4 minus 1 minus e to the negative x squared minus little r, which would be this guy right here, would be little r, which would be 4 minus e to the negative x dx. So that's your equation. You plug into your calculator, you get 6.748 roughly. Or if you want the exact answer, you would get 7 pi 1 minus natural log of 2. So there you go. That's the homework.